It's Mr. Roy again. Okay, we're going to look at a geometric series this time, and we're going to look at making an explicit formula and a recursive formula for that geometric series. So quick little reminder, geometric series means that we are multiplying the previous term to get to the next one. So a couple examples of what that could look like. Let me get my best green pen out here. So we could have a recursive formula where we're geometric sequence where we're doubling, right? We could have one where we start at 2 and then we double to 4, and then we double to 8, and then we double to 16, and then we double to 32, and then we double to 64, and then we double to 128, and we keep going. We could have one where instead of multiplying by 2 each time, we're multiplying by 5. So we could start with a 3, multiply it by 5 to make it 15, multiply it by 5 to make it, let's see, times 2 is 30, times 4 is 60, so that would be 75, and so on and so forth. I won't try and do 75 times 5 just in my head, but we're multiplying by 5 each time. We could do one where we are multiplying by a half each time. So that would mean maybe we start at 100, multiply by a half, that's the same as dividing by 2. So we go to 50, multiply that by a half, 25, multiply that by a half, 12 and a half. Okay, so each time we're multiplying by a half. We could even multiply by a negative number. We could say take our first one where we're doubling it, multiplying by 2, and we could multiply it by a negative number. So let's say we start with 2, and then we multiply it by negative 2. So 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. Positive 8 times negative 2 is negative 16. And then we go 32, negative 64. So you'll see if we have a common ratio that's negative, our numbers keep flipping back and forth. Their sign keeps flipping back and forth. Okay, so these are all geometric sequences, and each time we're multiplying by something. Now, the thing we're multiplying by we call our common ratio, our R value, right? So for this first one, R was 2. We're multiplying by 2. Second one, R is 5. This one, R is a half. And this one, R is negative 2. So each time, that's the that's the term we're multiplying by to get to the next term. So let's use one of these examples. I'm just going to get rid of these so I got some space. And let's choose one sequence and we'll do an explicit formula and a recursive formula. So here's my sequence of numbers, my geometric sequence. I'm going to say it's 4, 12, 36. Now, when we look at that and we try and figure out, okay, how much is that going up by? You may just look at it and notice that each of these, to get to the next one, we're multiplying by 3. Right? But if that's not super obvious, if you can't tell just by looking at it, there is the method you can use where you say, I'm going to take my third term here. I can pick any term, and I'm going to divide it by the one that comes before it. So that's 36 divided by 12, and you get 3. And then you can take, say, your second term and divide it by the one that comes before it. So that would be 12 divided by 4. That's also 3. So that tells us that our common ratio is 3. Each time we're multiplying by 3. Another important thing we might need to know is our starting value. Well, our starting value is right here. It's a 4, and we call that our A value. Sometimes it's also called T1 for term 1. Right? So that's going to be 4. So now we know our A value and our R value. Now our formula when we're doing a geometric sequence looks like this. That's our general term formula. The first number of the sequence times the common ratio. The common ratio is the power n minus 1. Not my best one, but it'll have to do. And then we're going to sub in our values. So what do I have for my A, my first term? It's a 4. So I'll put a 4 in. What do I have for my R value, my common ratio? Oops, I wrote R, but it's not R. It's 3. We figured out that it was 3. So let's put that in, 3. That's to the n minus 1. Now I can use this explicit formula to figure out any term I want. Say I wanted to find the 20th term. Well, I'm just going to replace n everywhere I see it with a 20. Okay, so far so good. Now, I got to do my exponents first. Don't dare multiply that 4 times 3 and get 12 and then put it to the power 19, right? We can't do that. We got to go exponents first. So that's to the 19. Let's go up here and keep working. So 4 times, what's 3 to the 19? I cannot do that one in my head. Let's plug that into our calculator. It's probably huge. It's a huge number. It's a huge number, but I'm going to write it down. 1, 1, 6, 2, 2, 6, 1, 4, 6, 7. It's a massive number. Multiply that by 4, and what do I get? This is my 20th term. 4, 6, 4, 9, 0, 4, 5, 8, 6, 8. So that's 4,649,045,868 is our 20th term in this big long string of numbers. Okay, so that's an explicit formula. Explicit means we can use it to find any term number we want just by subbing in for our n value, our term number. Okay, recursive is different. You can't do that with recursive, but it does tend to be a little easier to find numbers. So we're going to use that exact same pattern of numbers, 4, 12, 36. We're going to use that exact same pattern of numbers to find our recursive formula. Now we know our first number, sometimes we call it T1, means the same thing as 4, and our common ratio is 3. In our recursive formula, we always start by saying, what is the first term? What is T1? Well, T1 is 4. That's the first term. So that's done. Now we also have to put a little comma, and we have to say how we get to the next one. So we say, to get the next term, or any term, we have to know the term that came before it, and we write that t to the n minus 1. Okay, and how that works is, if I want to say find the 16th term, well, t to the 16 minus 1 would be t to the 15. So that means the term right before it. Okay, so I have to say the term before it, but I need to do something to it. What do I do to it? Oh, I multiply it by 3. Okay, well, I multiply it by 3. I can just put that right there. Usually, though, we would write it like this. We'd write the 3 in front, because normally we put the coefficient in front. So 3 times the previous term. Okay, so let's say I can't find any term I want. I can't go and find the 20th term because you have to know the term before, and I don't know the 19th term. But I can find this let's see, what do I got? I've got the first 3 terms. Let's find the 4th term. So the 4th term is going to be 3 times the, well, 4 minus 1, what's that? That's a 3. So 3 times the 3rd term. 3 times the 3rd term. Well, what's the 3rd term? Let's put that in because we know it. It's 36. Okay, so when we're doing this, we can just say, oh, all right, well, let's finish it off. So 3 times 36, 108. So now we know our next term is 108. If I want to find the one after that, using my recursive formula, I would say, okay, well, term 5 is 3 times term 4. Well, term 4 is 108. What's 3 times 108? 3 times 108 is 324. Oops, 324. Okay, so recursive formula just tells us What do we have to do to get to the next one? Okay, so I hope this has been helpful. Time to put these to practice. Remember, you've got the solution set to use that can be helpful, and you've also got, I'm going to make another video of the sequences of series practice, that Google Forms thing that you were doing in a group. I'm going to make a video with answers to those questions that you can use as well. Okay, bye for now.